all yours, SFT.
Hello, everybody. We are live tonight on Standing for Truth. Tonight, we've got NephilimFree and SpeedOfSound because this is the much anticipated discussion on evolution between these two fine gentlemen. So I want to thank them for giving us their time. I can guarantee you this is going to be a really, really good discussion. So, we're trying our hardest here on Standing for Truth to give the audience during these crazy times, streams, discussions, debates to listen to occupy some time while you may be stuck at home. We've had a lot of good discussions already this week. A few more by the end of the week as well. Tomorrow we're going to have a discussion between Raw Matt and Gutsick Gibbon. You guys may know her as Erica. We've also got next Friday, we've got Bill Morgan taking on Jordan. His podcast is Reasons to Doubt. They'll be discussing creation versus evolution and a couple other discussions in the works that we haven't 100% confirmed yet. But when we do, we'll let you guys know. So enough for me. I'm going to hand it over to the debaters. It's going to be more so an informal discussion and dialogue on various topics regarding biology, genetics, and evolution and creation, of course. If the debaters want to just give a brief introduction of who you are, what you've been up to, things like that, we can do that, and then we can go right into the discussion. Maybe we'll start with Mike.
Okay. I guess for some reason my screen wasn't working. Okay. For this, I am going to shut my cam off for a minute. Cam Mike, stop cam. I can do that. Okay. So I have a couple of questions. I like you guys, and I want to help you stop embarrassing yourself about this Darwin thing. What is this morbid fascination with Charles Darwin? I studied molecular biology and genetics for quite a few years, and I think I heard the word. I saw Charles Darwin together maybe 3 or 4 times during that. Darwin and natural selection are sort of like old school, and they've kind of gone by the wayside. And you guys really ought to let them rest and maybe go pick on Stalin or Hitler or Trump or something. He's not. It no longer represents the field, basically, to talk about Darwinism. And I've seen so many pictures of him on your channels. It's just driving me crazy. But maybe you could tell me what the obsession is with Darwinism. And the other thing is this, calling us evolutionists. It'd be like for physics is Faradayism, and anyone who believes modern physics is a Faradayist, it just doesn't make sense to call us Darwinists or evolutionists or whatever. Evolution is a really broad theory, and there is no way to falsify all of evolution because it has too many parts. So when you falsify something, you're not going to be falsifying the whole theory. I think what you guys mean by evolution is common descent, and you should probably say that instead, because from what I've heard, you buy into everything about evolution, speciation, mutation, all of that. And I don't see what it is exactly that you're calling evolution and claiming to refute, basically. I mean, if it's common descent or if it's non-biblical creation, is kind of what you're trying to promote biblical creation against non-biblical creation, which would be natural causes, right? So that drives me kind of nuts. But anyway, there was Darwin, and there was some early stuff, and then it combined with genetics and Mendel, and became neo-Darwinism, or I guess they call it the modern synthesis. And then between 1980, maybe even 70, and particularly at a conference in like 1986 or 1990, I think it was, it became the extended synthesis, and that's where punctuated equilibrium and a number of other concepts came into it, and neutral evolution and population genetics, and it is a very, very complicated field right now. And the more we discover about DNA, the more we find that's, I don't think it's surprising, but the more we find that it is helter-skelter. I mean, it's a pile of spaghetti code. And there are so many different ways that genes are promoted and proteins are created. And there's so many different things going on in the cell at many different levels, from vital to we don't care so much, to wasting some energy and time. And there's a lot going on in there. And I've seen a lot of papers fly by almost daily with new mechanisms, new ways that proteins can get created, or new ways that some RNA can be transcribed and do functions for a few ERVs that we found, which were, I guess, surprising. It's all surprising. I mean, we keep finding new things. So anyway, so I'm picking on you guys about how you frame all this, basically. And
Yeah.
really is Luca is not Luca is a population form. It is not a single cell. There's no claim that everything came from a single cell, that one cell did it. There was a population, and it was sort of a form of a population, and that's what happened way back in the seas when eukaryotes, 700 million years ago, when eukaryotes started. And that's another misconception that kind of drives me crazy. And I think that's about it for starters. But yeah, you can go ahead, Neff.
Okay.
Yeah.
Okay, actually, before you go ahead there, Neff, sorry. Thanks so much, Mike, for your introduction there. I do want to just point out to the audience, we'll probably have a shorter question and answer at the end of the discussion portion. We just don't want to keep Speed of Sound for too long. I know it's kind of late for you. So, but whatever questions you may have, just tag Praise I Am That I Am, and he'll make sure that those questions are answered at the end. And right when Neff is done with his introduction, Neff, take as much time as you need, brother. We'll go right into the discussion portion. It'll be just a free-flowing dialogue, and I'll leave it up to you guys to, of course, keep it respectful, equally timed, and fun for the audience. So that's enough for me. Neff, take it away.
Okay, so the problem I have with Darwinism, I think the point about Darwinism is to show that evolution theory was a philosophy and not science from the beginning. That it was an idea coined in a time when men knew nothing, almost nothing of biological science, virtually nothing at all. And so it was born in an era when we didn't know anything about biology, and despite the discoveries of science about biological systems, it's still held to with ardor and faith, just like a religion. My position is that the problem I have with evolution is that it's philosophy, it's not science. And the fact that evolution was born in that era of Charles Darwin, I think is evidence of that. That despite the scientific discoveries in biology, it's still held to this religious ardor and faith. And so the fact that evolution has changed from the Darwinian idea to neo-Darwinianism, and then to the new synthesis, and now it's on a third way. I don't know why my screen share is not working, but I'm attempting to screen share a web page here. But it's not working. I don't know what's going on with that. But my screen share is not working.
It's coming.
Okay, well, it's awfully slow for some crazy reason. But anyway, there it is. So this is the third way. Now, they make their statement against creationism. They've got to do that. They're going to put down creationism. But the reason that that evolution theory changes so much is because science never supports the ideas that they had before. Darwin's ideas of gemmules collecting and creating inherited change. Was of course disproved, right? So they had to come up with a new one, and then there was the new synthesis that random genetic mutations acted upon by natural selection. That was the new paradigm. That was the mechanism of evolution, and that's been discredited. Science hasn't supported that, so they've had to come up with what's called the third way. And in this third way, they're adding the ideas of phenotypic plasticity and recombination. So they keep redesigning evolution theory. They shouldn't have to do that, if you ask me, because if it were scientific, they wouldn't have to keep redesigning it every time they find out an entire new set of fantastic discoveries in science, specifically more genetics, that discredits what they've been telling us all that for the last several decades. Every so many decades, they have to redesign evolution theory because of the advances of science. That tells me it's not scientific. That's the problem I have with evolution, that it's philosophy, it's not science. And I have a great problem with that. Saying that, pointing to evolution as science, and when it actually is a philosophy, is the problem I have. I'd say the evidence that life was created is profound and overwhelming, and especially when it comes to genetics. If you ask me, when DNA was discovered, when it was discovered what DNA was, when it was realized that DNA was a four-dimensional package of information, then all discussion of evolution theory should have ended right then. It should have been over with. There should be no more discussion of it, because we have a package of complex information that prescribes how to manufacture an organism. That completely flies in the face of the reasoning that chance associations, happenstance associations of molecular components, that undirected natural processes order that. I mean, everybody knows that everything around them decays. If you buy a used automobile, you leave it in the garage, you pull it around back and leave it in the back because it broke down. You never get around to fixing it. You come back 10 years later and say, what am I going to do with this hunk of junk? And it's rotting, because everybody knows that chemists' job is to make molecules do what they don't naturally want to do. That's what every chemist's job is, to make molecules do what they won't naturally do. They have to force molecules to bond together in specific ways to make something useful. So why is it plausible to believe the most complex arrangement of molecules of matter, that is information, organized linguistically and operates algorithmically, could possibly be something that natural chemistry can make, when chemists have to try to force, with astonishing educations, to force molecules to assemble in ways they don't naturally assemble. See, evolution is counterintuitive. It flies in the face of science. So I say that natural chemistry would never produce a DNA molecule to begin with. It's not going to happen. There's no natural chemical process that can make the sugar ribose molecule. It's made only in the presence of enzymes, which themselves are proteins, which are made by a cell. You have to have a whole cell to get a protein, and you won't get you won't get the sugar backbone of the DNA or RNA molecule without them, because there's no known chemical process in nature that can produce ribose. So already you're stuck with the intelligent design. It's interdependence which can't be broken. It's irreducible complexity. But I think the hardest hitting destroyer of evolution is the fact that we've discovered that DNA is information which is linguistically organized, with linguistic properties that are more complex than any spoken human language, and that operates algorithmically. Now, here's the thing I could show you more information about the linguistics of DNA, but just think about this for a second. DNA operates algorithmically. An algorithm is a process designed to produce an end result. It requires forward thinking. Somebody has to think about what needs to be accomplished and go through an order of prescribed steps to achieve a goal. Now, if life was a product of chemistry, and all chemical processes take place in the present. There are no chemical interactions taking place in the past. That's already done. There are no chemical interactions taking place in the future. There will be, but all chemistry takes place in the now, in the present. How is it rational, therefore, to believe that that if evolution is a chemical process, and it must be if it were true, that chemicals are able to consider what must be accomplished in the future, which would relate to chemicals that don't yet exist under conditions that don't yet exist in order for them to have a purpose? See, this to me just blows evolution completely out of the water. The fact that we have discovered that DNA operates algorithmically kills evolution theory once and for all, because it requires forward thinking. And you can't, it's implausible to believe that chemical interactions happening only in the present are able to set up a system of process by which they are dependent. The purpose of their very existence is dependent upon molecules that have not formed yet and under conditions that don't exist yet. So the fact that we find information linguistics and algorithms in DNA, to me, it kills evolution theory. So I'd ask you, Mike, do you think it's plausible that chemical interactions happening in the present would be able to design a system of actions that would be dependent on the existence of molecules that are yet to form under conditions that don't exist? Is that plausible to you?
I don't. You kind of loaded that up, but okay, we've been all over the place here, from abiogenesis all the way up to the present. But yes, maybe instead of a debate, maybe you ought to figure out exactly what it is that we really think and why we think it. Now, I noticed you went from what I can't logically connect with what you said is you went from there's an algorithm. Okay, there are and or gates and not gates in DNA in how a cell works, and you went from that there is an algorithm. You went from that to there has to be forward thinking. There has to be a mind. And I will say that is your worldview interfering with the way you're thinking. And my worldview, I guess I'm stuck with the idea that there is no God, that nothing created it. So, I mean, I pretty much have to try to find natural causes for things. Like, for instance, I started out as a single cell, a single fertilized cell, and somehow I became this thing, And I think and I build things and I read books and I'm having, a talk with you. That was magical, but that was all. We can explain every single piece of that about how I developed. We know that. We know it's natural. We know there was no divine intervention in me coming from a single cell all the way to this multicellular thing that has amazingly stayed alive for 69 years. I made it through the 60s, for Christ's sake.
Well, if we know that it's natural, how is it that its properties of mind are behind its function, its operation? Like an algorithm, you didn't actually address my question.
Okay.
And algorithms are at the basis of how DNA functions.
The part of the modern synthesis. Well, okay, we've got to go back to something that you started with, and you started with the fact that we've redefined. I mean, after Darwin was an old dude that died like over 120 years ago or something. He died a long time ago. He did not know anything about DNA or modern science or cell biology. I mean, we know a lot more today, and the more we learn, the more we refine. And right now we have mutation, recombination, gene conversion, duplication and divergence, or duplication and divergence, duplication and subfunction, de novo origin of genes. We have copy number variation. We have ERVs. We have exon shuffling, pseudogenation, and de novo, or basically divergence of pseudogenes into functional genes.
You're talking a lot about things, but you're not answering my question.
Okay, I'm trying to, and we're going to get there. The modern synthesis has a number of things, and you basically, how can you accuse science of doing what science does, which is changing the model all the time, making the model more and more complicated, more specific, throwing away what doesn't work, and adopting new things that do work. Now, all the same stuff is still in there. Natural selection, purifying selection, and negative selection, or positive selection, are still part of evolution. They're not the backbone anymore. They're not the go-to. There's all these other things that have happened as well. So, I mean, I'm pushing back against you're saying it's not science because we changed the science. I mean, in 1969, we went to the moon with a certain kind of rocket. Our rockets are better today, and we've thrown away a lot of that technology, and that's what science does. So, I mean, how does that work, Nev? That we're not supposed to change evolution just because Darwin came up with an idea 150 years ago? I mean, that doesn't make any sense.
Well, it makes sense to me that that the theory has to be changed constantly, and punctuated equilibrium is another example of that. The fossil record proved, by the 1970s that scientists were literally throwing their hands up in the air. What the heck is with this? The fossil record doesn't show us the transitional forms we expect, and it never has. And so they come up with punctuated equilibrium. They've got to redesign the theory to fit the idea. But now my question to you was about algorithms. I asked you, is it plausible to believe that chemical interactions that are taking place in the present is it plausible to believe that they would be able to set up a system of operations that are dependent on the existence of molecules which have not yet formed under conditions which don't yet exist? So to believe that evolution is true, you have to believe that evolution was capable of designing these algorithms in the cell that operate things like the ribosome and the polymerase machine as it reads the information from DNA to compare information and find what it's looking for. Search algorithms and functional algorithms in the operation of the ribosome. So the question is, if evolution is a purely natural process and not designed by an intelligence, and the only place we know of where algorithms come from is from intelligence. That's the only example known. All examples of information algorithms or semiotics, which is a part of linguistics, all of them, there are no exceptions, all of them are produced by intelligence. So the question is it plausible to believe that intelligence is the designer, therefore, of the organism, since it operates by algorithms? And if you say no, you have to believe that natural processes is able to design an algorithm. An algorithm is a series of processes designed to produce an end result. Typically, it involves comparing information and making a choice about what information fits the model. So how in the world is it plausible to believe that chemical interactions, which always take place only in the present, are able to produce a system of operations designed to find information which does not, with chemicals, with interaction with other molecules that are not where they would need to be and may not even exist yet under conditions that don't exist yet? How can natural chemistry do that?
Okay. First of all, a classic example of semiotics is bear tracks, or you follow tracks in the woods, or you follow the curve of a river or whatever. These are signs. Okay, semiotics is about signs. Signs can be perfectly natural and not require intelligence. So when you say semiotics, be careful there that you want to read some of the source material on semiotics.
Oh, I have.
So with
semiotics is the application of a meaning to a symbol, or the interpretation of meaning from a symbol.
It's
a mental process, not a chemical one.
But the symbol itself does not have some innate meaning. It has meaning only in the person that finds it. But let's not go down that rabbit hole.
A bear track is not a symbol.
It is. It's a sign.
No, it's just an imprint in the dirt. A symbol is something that has meaning.
Who was it? Putnam that did the original semiotics. I can't remember. I've got the books in there. They talk about tracks and things like that as the basics of science.
That doesn't qualify as a symbol, Mike.
I could show you some philosophy. Anyway, but that's a rabbit hole. Now, we were talking about algorithms. A river following a curve, a bend, following a bend is an algorithm, okay? Molecules follow algorithms. Crystals follow algorithms when they form. Are you familiar with these robots that they've created where they simulate ant hills. They've given them like 3 or 4 very simple programs, very simple and/or gates, that sort of thing. And these simple programs result in emergent complex behavior. And that emergent complex behavior is what happens in the cell. And now, if you had a can of gunk in your garage, 5 gallons of it, there isn't enough complexity, and there wouldn't be enough time for that to predict or create an algorithm that was going to create some sort of a life or some sort of a system that works in the future. But if you have something the size of the Earth for 4 billion years, then you have the complexity and the time for something to be created, or enough different complex systems to be created that they can predict a great deal of the future. So far, we've made it 4 billion years, or 3.5 billion years of life. And this is an understanding of what happens at the chemical level with DNA, understanding why these guys, Sung Chul Ji, linguistics of DNA, word sentences, grammars, phonetics, and semantics. The reason why they're bringing this into biology today, it's part of the extended synthesis. They're bringing in this idea of information and complexity into biology and systems, and dynamical systems and emergent behavior are dynamical systems. And this is something that you only grasp if you get down and dirty and start understanding the chemical interactions and what they are capable of and what the cell's capable of. And life is an amazing thing.
I'm not hearing any explanation of anything. I'm hearing.
What level do you want?
Well, firstly, I didn't get an answer to my question about algorithms. I'll put that aside because I don't think you can give you're willing to answer it directly because I don't think it's possible for you to give a logical explanation.
I think it is.
Excuse me, as to how an algorithm can form naturally, because it requires forward thinking. But now, excuse me, when you're talking about semiotics, you're misrepresenting semiotics. Semiotics is the application of meaning to a symbol or interpretation of meaning from a symbol. It's not a bear track in the ground. That's just an indentation in the soil. It's not a symbol. It's what the animal left behind. It doesn't have meaning. There was no meaning applied to it. A meaning applied to a symbol is semiotics, or interpreting meaning from a symbol. Symbols are not something that occurs naturally. A symbol is something that an intelligence has implied meaning to. That is what a symbol is.
That's your worldview. That's the
description of. If you look up semiotics in any encyclopedia, you'll find that it always entails mental process.
The study of signs and symbols and their use or interpretation. Basically, semiotics is the interface between man and these symbols, basically. But there are many forms of algorithms that do not involve any intelligence at all. They're machines.
That's not so. No, that's
basically
not so.
Mechanistic, yes.
No. An algorithm.
An AND gate in your computer does not require intelligent intervention.
Let me give you the definition of an algorithm. And Webster's dictionary describes an algorithm as a procedure for solving a mathematical problem, as of finding the greatest common divisor, in a finite number of steps that requires intelligence because somebody has set the system up already to limit the number of operations, in a finite number of steps that frequently involves repetition of an operation, broadly a step-by-step procedure for solving a problem or accomplishing some end, especially by a computer. So there is no definition in any academic source of an algorithm that defines it as something found in nature. What you find is people will say, I can make an algorithm out of what I find in nature. An algorithm is something that has function. That what you're finding in nature is not an actual algorithm. That's just something that's naturally there, and you're building an algorithm by comparison. It's not actually an algorithm because it doesn't have any function.
You're right.
Algorithms
DNA is not actually
what
No,
You just said
DNA possesses
All
algorithms
right.
that have purpose. They
It
have
has
function.
consumption through
They're
flames or
what you
disease.
find in nature that you
No, you said
think
we
of
look,
algorithmically
we look at
doesn't have a
something.
function.
You said we look at something in nature and we apply the idea of an
If you
algorithm
could
to it,
take
but it's not
hell
really
from
an
the Bible,
algorithm.
which
And the
most
difference is
Christians
function.
have today.
DNA is not an algorithm.
No, the difference is function. The algorithms in
Then you
DNA
could
are functional.
accommodate-
They have a purpose. They have a goal that they are
No, they don't.
achieving.
They just make.
Well, wait a minute. You just said you don't believe genetics, Mike?
They just make a living thing.
No, algorithms in DNA are
use the
functional.
word function. We can compare them to something that we made. We can compare them to our computers, to our machines. We are a tool-making ape.
Let me screen share
We're
something with you
tool-making
if I'm
primates.
able. I don't know how to get this to show up on the screen. I tried screen share, but it's not showing up. Praise, is there something that I need to do or you need to do to make it happen? Because I just see my eye there. Okay, thank you. Okay, so this is algorithms. Just let me try to get that full screen. This is from a science paper published in 2012 titled Dichotomy in the Definition of Prescriptive Information Suggests Both Prescribed Data and Prescribed Algorithms. Okay. Now, the reason they say it's a dichotomy is because they can't find a way for natural processes to produce it, and it produces a dichotomy for evolution theory. In other words, it's a major problem. They don't know how to explain genetic algorithms with natural processes. And they state, an operational analysis of the ribosome has revealed that this molecular machine, with all of its parts, follows an order of operations to produce a protein product. The order of operations has been detailed in a step-by-step process that has been observed to be self-executable. The ribosome operation has been proposed to be algorithmic. They call it an R algorithm because it has been shown to contain step-by-step process flow of decision control, iterative branching and halting capability. The R algorithm contains logical structures of linear sequencing, branching, and conditional control. All of these features meet a minimum at minimum the definition of an algorithm, and when combined with the data from mRNA, satisfy the rule that algorithm plus data equals control. Remembering that mere constraints cannot serve as a bona fide formal control, we therefore conclude that the ribosome is a physical instantiation of an algorithm. The correlation between linguistic properties examined and implemented using automata theory give us a formalistic tool to study the language and grammar of biological systems in a similar manner as we do study computational cybernetic systems. These examples define a dichotomy that means a problem for evolution, a major problem, in the definition of prescriptive information. Wherefore, we suggest that the term prescriptive information be subdivided into two areas: prescriptive data and prescriptive executing algorithm. So you see, the difference is what.
Excuse me. Are you reading? I can't see your screen. Are you
Okay.
reading D'Onofrio?
Yes.
D'Onofrio? Okay.
The point of it is that algorithms in DNA have function. They have purpose. They're not something found in nature that man can look at and say, I can build an algorithm out of. These have, because those things you're talking about have no function. They don't qualify. What we find in DNA is something very different. These operations, step-by-step procedures, have choice contingent controls. The choices are involved. That means a mental process, and they have an intended purpose. That's very different from looking at something, an arrangement of trees on a hillside and building an algorithm out of it in your mind. It doesn't have a function. What's algorithmic in DNA is functional. Function implies design. So when we look at things that are designed, there's a couple of criteria we look at. One is complexity. How complex is it? Is it modestly complex, or is it stupefyingly complex? When we find things that are astonishingly complex, we infer automatically that they've been designed by someone. When we find, the second criteria would be specificity of order. For example, in a protein, the specificity of the arrangement of amino acids in a chain that results in a very specific form of a protein that has a particular function in relation to other proteins. It's so specific, in fact, that their one is designed to match with the other so that they bond in such a way that their shapes produce a mechanical function. So they're interdependent. So the specificity of order. Now, when we look at natural processes, we don't see nature naturally ordering things in highly specific ways to have a function. That's a hallmark of design, right? So when we look at these things in nature, like an algorithm in DNA, we see something designed because we see its specified order arrangements with a function in mind. The function is necessary. This is not what you're describing about nature. It
You
has
see it designed because you're looking through your design toolmaker glasses.
no, because it has function.
Okay, will you give me a chance to respond? Okay.
Address function, please.
Okay, for one thing, you're all over the map again. You're all the way from abiogenesis all the way up to the ribosome. Ribosome is 3.5 billion years in the making, basically. So we got to pick something a little more fine-tuned than talking about the entire eukaryotic cell mechanism, okay? Because I cannot explain that all to you in the next 25 years even. We couldn't scratch the surface. Okay, so we got to start somewhere. So the life has some amazing complexity. The one thing about life is that it's autopoietic. It's a self-organizing, self-building system. There are such systems, simple systems that we've done in the lab. When we do things in the lab, when we do biology in the lab or biochemistry in the lab, we start with very pure, clean glass, purified reagents, and we try to decipher one particular part of it. Okay, the cell is not like that. The cell is a self-replicating system. You know it's self-replicating because you're self-replicating right now. You started out as a one cell, one fertilized cell, and without any intelligent design, without any intelligence, without any foremen or operators or factory workers, you were created. So we know that something magical can happen with chemistry, correct?
No, I disagree that I'm not a product of design.
So you were created by intelligent design?
Absolutely. The information package that prescribed what I would be was
the information was there when you were born. Starting when you were born, we're going forward. We're looking at the magic that happens after the DNA is there. We're not going to talk about all the way back.
I'm a product of that information. No, I'm a product. The information that defined what Evan Phillips would be was already written. Okay, I'm simply a product of its expression.
Sorry, I didn't recognize. Okay, the information to create you was not just in that DNA. That DNA will do nothing all by itself. It will just decompose. It's just a chemical. There's a sequence there, and that sequence has a great deal to do with what you are today. But without the world, without the natural world around you as you develop, without your mother, without those enzymes that were in your mother's cell arranged in a certain gradient, you would not exist. DNA could not have done that all by itself.
DNA did it.
On life. No, it didn't.
No, I'm a product of that DNA.
No,
every organism is a product of their DNA. The features you have and the biochemistry you have is directly a product of your DNA.
DNA does not have enough information to create you.
Well, then how do you come into business? Because your parents didn't design you. Who built you? No, it's the information expressed over time that makes you.
They loaned me a cell that basically.
Well, that's not the information.
That was a living cell that I came from.
Well, you're talking about cortical inheritance.
Living cell, and my grandpa did. There's life. Life is like overlapping circles. We're all part of the same living thing. All life on Earth is all part of the same organism, and it goes from one to the other. The DNA is not enough. Now, there's a great deal of sequential information in that DNA, and I'll grant you that. But how that sequential information got there was incremental over 3.5 billion years.
I think you're misrepresenting the facts. The fact is, we require the cell, the cortex of the cell has its own information and its physical design. That's correct. But you're talking about directed assembly, cortical inheritance, also called cytotaxis, which points to special creation. You have a cell cortex that's uniquely human because you got it from your parents and they got one from their parents. It goes all the way back to Adam and Eve. The same reason a chicken is a chicken is because it got a cell, has a chicken cortex, is because it got their cortex from a chicken, which got theirs from the first chicken and from the very first chicken. This is one of the stronger evidences against evolution. You're putting something that kills evolution theory. But when you're talking about there's not enough information in this in the DNA to make a human being, that's you're grossly misrepresenting the facts. The information in the cortex of the cell is not what defines where your features are in your body plan, or how they're going to be designed, or how to assemble, how to specialize cells so that there'll be a liver cell, a kidney cell, heart cell, or a nerve cell, and how to organize these billions of cells to create an organism. That's the information that exists in the DNA. And you said it's not enough, but in fact it is.
What is a cortex of a cell? What are you talking about?
I'm talking about the organelles, the structural design of the cell membrane. This is what's passed on only by heredity.
No, but there's more than that. There's all kinds of enzymes.
The point is the cell is passed on by division. It's not developed by genetic information. This is evidence of special creation.
Why?
Not design. Because the cortex is, I'll say it again, the cell's design is not developed by genetic information.
That cortex thing, and what theory are you talking about exactly? This
cytotaxis, directed assembly, cortical inheritance. The cells reproduce by division. They split everything. The organelles in the cell split. The DNA splits. The membrane, it splits. Cells divide. That's how they reproduce. Cells don't come into being because genetic information says build a cell. The cell that already exists splits. Cells are not developed by genetic information. They're passed on by division. This goes all the way back to the first cell. This is evidence of special creation, not evolution. Cells do not come into existence by
cells
genetic
never
information.
changed, it would be. I mean, if the cell had to be the same all the time, but it's different every time it divides, all the way back 3.5 billion years until you ended up with little clay pockets and not cells.
Well, that's your philosophy. That's not science.
No, it's not my philosophy. I understand a great deal of the chemistry that is involved.
There's no science that supports that.
The first chemistry you have to understand is what happens after mama's cell gets invaded by daddy's DNA and starts to divide and form you. And that's,
but they have human cortices.
That's the thing that you should understand. This cortical theory, is this like, it sounds old.
It's factual. I mean, this is, Mike, try to understand this. Cells don't come into existence by developing in part.
No, yeah,
they're not built. Okay,
yeah.
They come into existence because a cell divides into two, and you have two duplicates, right?
Overlapping circles all the way back to evolution to the
first cell,
to the first cells,
right?
To the
of human cell, the first human cell.
To the first lipid bilayer, basically, or even before that.
Well, now you're talking philosophy.
No, it's not
science that supports that.
We know a lot about that science.
No, abiogenesis doesn't have support.
Abiogenesis is a science. I have many books on it. I have tons of theories. The problem is that we can't look 3.5 billion years backwards and figure out exactly what happened.
Yeah, I know. I don't think you can show any science that supports it. Nobody has shown any scientific support for evolution. Mike, some of the most prominent minds in the origin of life have said, let me share with you a thought or two.
I don't want to hear a quote.
Let me share with you a thought about that. You know who Eugene Koonin is? He's a microbiologist at the National Center for Biological Information. In 2011, he said this: the origin of life field is a failure. It's failed. Yeah, they haven't found any kind of chemical process that's able to produce a cell and its features. The idea of abiogenesis has not. There is no scientific support for it. Yeah. All they have is the idea that a lipid sphere can produce a cell and a precursor to a cell membrane. That's it. That's all. Nothing more. Nothing. Okay, so the origin of life field has failed, utterly failed.
Okay, Eugene
Robert,
Koonin, where is he from?
well, he's a microbiologist at the National Center for Biotechnological Information. He's a staunch evolutionist and an eminent scientist.
You know
Now,
what?
Robert Shapiro has also said the sudden appearance of large-scale self-copying molecules such as RNA is exceedingly improbable, so vanishingly small that it's happening even once anywhere in the visible world would count as an exceptional piece of good luck. And
Yeah,
and,
my
and
mom
many
said I
other
was gonna-
scientists have said this. So when you say we've got scientific support and abiogenesis is somehow documented, no scientist, Mike, has
no
ever
scientist. You got
documented
that
a
one
process
guy,
which can produce a cell.
Evan. My mom told me I was going to be a criminal. Okay, she had an opinion. This guy's got an opinion. There's a lot of guys with opinions about abiogenesis. A lot of them should keep their damn mouth shut and actually go and work in the field. There's this guy. He has an opinion. He pointed out some problems, the difficulty of the problem. It is a difficult problem. But like I say, I have a half dozen books in there on abiogenesis, and they have more theories than you could digest in 10 years. Okay. And there are people that are looking into this. We don't know what happened.
Of course, they're looking.
And on the other hand, you don't quite know what happened on the day of creation either, do you?
You don't know what happened. There you go. So that's the truth, Mike. Origin of life field is a failure. Scientists involved in that
how
field.
it could have happened. We know,
Mike. Nobody knows how it could have happened. Nobody knows how it could have happened.
Oh yes, we do.
No.
All kinds of ideas.
Mike, what you're stating is untrue. You're telling people that something that's false. So no scientist, no origin of life scientist, none have ever said we've got things figured out well enough that we know how a cell came into existence. There isn't one statement, Mike. There isn't one statement like that in any paper. None.
That would say what? That say we know.
That say that they have figured out how a cell formed.
No, we haven't. I told you we don't know.
Right.
We don't know which mechanism it is.
So they don't know how it could have happened.
1,000 ideas about which mechanism it is. I mean,
they have ideas, but none of them have worked out.
Did I dream that I read all that I looked into all those books?
Mike,
have you read any of them?
Mike, when you find a statement in one of those books that says we have figured out how a cell could have formed naturally,
no. Statements, are not going to get you there. You're going to have to read the book and understand the chemistry.
Well, you've already admitted that we don't know. That's all I need to know.
We don't know how it happened. You don't know how creation happened.
Right, we don't. We don't have a scientific explanation for the origin of life. That's true.
And you
the
don't
field
know
has
how
failed.
creation happened.
Well, we have the inference that life is designed, that it was created, and one of them is cortical inheritance. The fact that you have the fact that you have a human cell because you got it from your parents, who got it from their parents, who got it from their parents. We know that's what happened because cells don't develop; they split. They don't develop. And so you have to believe that cells developed.
I am not,
but science doesn't show us that.
I don't.
Science shows us only that cells come into existence by splitting, not by development. Your theory, your philosophy is that they developed in the beginning, and they've been splitting ever since. But that field already, as I've said, is a failure.
There are cells developing today, all over, out in the forest.
Where?
Everywhere.
What cell has been observed to come into existence by development?
Observed? How are we going to observe everything in the forest?
What cell has come into existence by development, Mike?
How many cells are out there,
Mike, what cell has been observed to come into existence by development?
Into existence? I said, I believe I said that they're changing. Okay.
Wait, no. You said you said that they're developing.
Developing,
what cell has been observed to develop? What scientist says a cell has been observed to develop instead of?
There are cells out there developing right now, changing from one kind of cell into another.
That's not developing. That's specialization. That's not developing the cell. No, the membrane, the cortex doesn't change. The cortex doesn't
problem change. With this idea between anatomy and morphogenesis, morphology or whatever, where you make a distinction between anatomy and morphology. You have to look.
There is a distinction. That's why they have different definitions, Mike.
Okay, all you're doing is telling me your worldview, giving me your intelligent design idea, and stating it over and over again. Okay,
Well,
we're not
well,
getting
Mike,
into the details. You're not getting into the details.
let's recap a couple of things. You said abiogenesis is highly supported. I showed you a statement from one of the men who's been involved in
Did I
life
say it was
studies,
highly supported?
who said that we don't have a clue.
I
It's
said we
failed.
have a lot of ideas. I said we have thousands of
Okay,
ideas.
right. And then you admit that. And you said the information in
Well,
the
you don't know
genome
what
is
that
not
is, right?
enough. You said the information in the genome is not enough to produce an organism, when in fact science knows that is exactly how an organism comes into existence, by the expression of genetic information.
Well, I know how
So
that
that was not true. Now
I
you're
know
telling
that
us that
happens.
cells
You know
have been
how that
observed. Now you're telling us that cells have been observed to develop, when no scientist has observed any
I
such
never
thing.
said observed. You said that. You put those words in my mouth.
You said
I
cells are
said,
developing
they're
all over the
developing
place.
out there right now. I said cells are changing right now.
No, you said developing. You said cells are developing.
Right
No
now.
scientist has ever observed a cell to develop.
No, we haven't caught one. Well,
Okay, great.
maybe we
It's
have.
never. It's not known to happen.
Have
The
you
only
checked all
way,
the papers? Have you checked all the papers? Are you sure we haven't caught one changing?
Mike, are you telling us it's not true that
Actually, we have caught.
Are you telling us it's not true that the only process known to science by which a cell comes into existence is cell division? That there is another process that scientists aren't telling us about? Is that what you're saying, Mike?
I believe they've had some luck with making some artificial cells, but I don't know much about it. But anyway,
that's not developing.
yeah,
That's man. That's an example of intelligent design. Man trying to do something.
no. Okay,
But
wait a
I'm asking you a serious question.
talk for 5 minutes and let me put out
Well, Mike, maybe if you'd answer one of my questions. One.
Go ahead.
Well, you don't answer any of them.
Well,
The question was, you said we cells are developing. Did you misspeak? Did you misspeak?
no, I said cells are developing. I did not say we are observing.
And my question then is, who has observed a cell to develop? What science has documented cell developing?
I don't know. I didn't.
Well, I'm going to tell you none.
Okay, you're when you ask the question, you put the word observe in there. I said there's a force out there where evolution is happening all over the place. How the hell are we going to observe it all?
Okay, Mike, I'm just going to tell you this. There isn't one biologist on this earth, none, that would agree with you about this idea that cells develop. They might believe in abiogenesis, that a cell did develop in the past. And if you believe evolution, you should be believing that it's happening today, unless the Earth's environment so changed. But to prevent it. But here's the thing, Mike, you're saying that cells are developing, and no scientist knows of any such thing. The only way cells come into existence is by division. That's the only thing.
There are probably 1,000 papers out there that talk about cell development, evolution, mutation, change.
Right, that's abiogenesis.
New proteins. What?
That's abiogenesis. Cells have never, or it's not known that cells develop. The only means the cells come into existence that is known to science is division. Cells divide. They split the organelles, you get half, I get half, and you get a new cell. Okay, that's the only way known to science.
You're confusing the word develop with what I meant. Okay, cells develop, they change. When cells...
Okay, so that's why I asked you if you misspoke.
When cells divide from one organism to another, when that DNA is recombined and passed on, the gamete becomes a zygote, okay, there is a change in that cell. It's always different. You believe in genetic entropy, right? So you admit that things mutate, so you know that cells develop. They change from one thing to another.
No, that's not the development of a cell.
What are you talking about? What do you mean by
what you're talking about is cell specialization. You're adding the idea of random mutation to cell specialization.
No,
it's not appropriate.
How is
cells specialize?
How is mutant cell specialization?
The cell doesn't come into existence by
You're
development.
Playing games of words.
No, Mike, you are.
What do you
Cells
mean
don't develop.
What do you mean by develop?
No, well, we're talking about come into being. Its components arise when they didn't exist. What else could I mean by develop? I'm not talking about specialization.
I don't believe things come into being. Okay.
Okay. Well, Mike, cells that specialize. When a cell specializes, it doesn't get organelles. It already has all that. It specializes, but that's not the same thing as develop. Okay. Cells don't come into existence by development.
It doesn't have all of its organelles. It builds a bunch of them. Okay, cells develop.
No,
Cells
cells don't
develop
build
all the
organelles. They get them by division.
They get them by division. No, they build endoplasmic reticulum. They constantly rebuild their membranes.
That's not organelles.
Organelles.
The
Okay,
organelles are divided when the cell splits.
Lysosomes. They build peroxisomes. They build.
None of that is organelles.
What is an organelle?
Mitochondria, ribosomes. I mean, not ribosomes. These major features of the cell, they split.
They're part of the
They
whole
divide.
process.
Cells don't develop, Mike. They specialize. They don't develop.
Okay, so you mean by develop come into being like God made it, right? God created it.
No, what you're talking about is naturalism. So you would have to believe by develop. You would. I mean, I think you misspoke in a very grand way.
How do you think the first cell developed? How did
it didn't develop, Mike. It was puffed into existence when God spoke. Into
existence.
That's right. Yes.
So you believe puffiness, and you're making fun of my idea.
Yes, absolutely. Absolutely. Cool. And cortical inheritance is one of the reasons we know that happened, because the cortex of a human cell is not the same as that of a chicken cell. So since cells divide and they get their structural design by division only, then there was a first human. That's the inference we got. But your idea is this idea that cells originally developed, which there's no scientific support for. So that's all.
Basically, every time a cell divides, it changes. Okay, do you understand that? It cannot be the same thing. Exactly.
It doesn't get new components.
Most cells are twins. Okay, it doesn't get new components. Okay, you're splitting hairs there.
Well, organelles don't come into existence by develop; they split.
Organelles are built by DNA. A lot of organelles are built.
No,
mitochondria, that happens by division. The cell happens by division. The nucleus happens by division. Okay. Everything else can be built. Everything else.
Well, you're talking about subcomponents. I'm talking about the major components.
Okay, you're splitting
the cortex of the cell. Okay, the ribosomes are going to be built by the cell after division, right? It's already got some, by the way. Is it
when a cell splits? Are they identical?
Mike, I don't see any support in evolution in cells division. I don't see that.
Identical. Identical when they split.
Well, in the structural design, they're the same. Yeah.
Is your DNA identical to your parents?
No, of course not. Not exactly identical. So extremely close, but a little bit different.
Not in a positive direction. I don't know.
So how does that support evolution? Because of so the evolutionist is going to say change occurs to DNA, thus evolution. I don't see that. How does change to DNA support evolution, Mike?
How are we going to talk about that when you're using overall languages and ideas of intelligence? If you want to talk about how evolution happens, you have to talk about science.
Well, just tell me. That's what I'm talking about is science, Mike.
No, you aren't.
I'm asking you, how does change to DNA constitute evolution? How does that support evolution theory? Because DNA can change.
We have to have an example, don't we?
Well, I'm just asking the question. You can answer it the way you want, but as long as you answer it directly.
What happens to DNA when it mutates?
Well, pairs get changed. Nucleotides get swapped with other ones. Things like that happens. Okay, so the question is, right? I'm sorry?
So the code changes.
So the information can be modified by mutation. Yes, everyone understands that.
So it creates a slightly different protein.
Mm-hmm. Okay, so what you're saying is protein mutation is evidence of evolution, then, right?
Yes, of course.
Okay, I say it's an evidence of going downhill. Mutations, protein codes.
How do you know that it goes downhill?
Well, I'll tell you how I know it. Because when mutations, the overwhelming examples when it comes to mutation in protein is that when a mutation occurs to a protein code in the DNA, it causes either a reduction in function, efficiency in its protein, or it causes it to be completely non-functional.
Who told you that?
The science journals.
Okay,
The
tell me
science
how that
journals.
works. Tell me how that works at the chemical level with proteins.
Let me give you an
Okay,
example.
we've got 3 alpha helices. We have a beta sheet, and we have a motif
I'll
that
give you an example.
correlates something. Okay.
See, this is your fantasy belief that mutations can modify proteins.
Talking about chemistry, Neff. It's not fantasy. We know chemistry.
Well, let me show you why it's fantasy, Mike. This
Why is it fantasy?
idea that mutations occur to proteins and they keep building viable functional proteins is antiquated pseudoscience. Let me give you an example. This is from a science paper called Stability Effects of Mutations and Protein Evolvability, published September 2009. The paper states, the past several years have seen novel insights at the interface of proteins, biophysics, and evolution. The accepted now listen carefully. The accepted paradigm that please listen carefully. The accepted paradigm.
Give you the name of the paper.
I did. Stability effects of mutations and protein evolvability. They state the accepted paradigm that proteins can tolerate nearly any amino acid substitution has been replaced by the view that deleterious effects of mutations, especially their tendency to undermine the thermodynamic and kinetic stability of protein, is a major constraint on protein evolvability. The ability of proteins to acquire changes in sequence and function. Mutations and mutations that alter protein function in particular are generally destabilizing and can reduce protein and organismal fitness.
Did you see that word general?
This is what's commonly published in the science journals when it comes to what happens to protein codes that get modified by mutation. Is it typically produces a protein of reduced function or non-function. It doesn't create new function.
Are you looking at Bigman? Is that the paper? Lavi S. Bigman?
No, not Bigman. This paper is by Nobuhiko Toriki, I forgot, and Dan S. Tawick, published in ResearchGate Publications. Let me provide it for you on the screen, okay? I'll try. I don't know. My screen share stuff doesn't seem to work too well. I don't know what to do. I'll paste the name of the paper.
Okay.
In the chat. Okay. And for this room. Okay. So what's been discovered is that proteins, when they're affected, this is supported by numerous papers in the science journals. It's everywhere, Mike. It's well known in science. When mutations modify protein codes, the effect is almost always degenerative. Almost every single time.
Did you see that word generally?
That's right, generally. What does that mean?
Always.
Right, that means, right. And the exception to that is it's rare that one amino acid can be substituted for another and still provide exactly the same function. That's rare. And it's one of the reasons it's rare is because there's 20 amino acids. You got a 1 in 20 chance of getting the one that's going to provide the same function. 1 in 20. And that's assuming all kinds of conditional things. So in general, that's true, that when proteins are affected by mutation, the result is negative. And that's why, Mike, almost every human disease is a product of a mutated protein sequence.
I have a cat throwing up in the background. I'm
sorry to hear that. So this idea that proteins evolve by mutation is counter to what's published in the science journals. It doesn't make sense because we know from the repeated publications in the science journals that it's been observed that the overwhelming effect of mutation upon protein codes is a protein of reduced efficiency or no function whatsoever. So where do you get the idea then?
The
mutations build proteins.
We summarize recent findings regarding how mutations affect protein stability and how stability affects protein evolution. This paper talks about protein evolution. When they talk about protein evolution, now I'm hoping you can be quiet for like 1 minute, okay? When they talk about protein evolution, they will say that most of the time, okay, something goes wrong. But
yes,
not really, because proteins can withstand a great deal of mutation.
Oh, no, Mike.
Now, hold on a second.
No, 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 no.
You don't know what a protein is, do you? Okay.
What scientist has ever said that?
Hang on a second. Protein is, okay.
What scientist has ever
You've
said
got
that?
alpha helices. You've got some beta sheets. Okay, if you change something in that alpha helix, it's not going to destroy the alpha helix unless it changes to a proline. And even then, it doesn't always wreck the alpha helix. Sometimes it bends it. Okay, and then most of the protein is these chaotic loops that form around it. Those things can withstand a great deal of change. So not every mutation is going to change the protein. Okay,
Mike,
hang on a second. I'm still
okay.
talking, man.
Okay.
And there's one important part of a protein, and that is the motif, or some of them have multiple motifs, like our DDX11 has 9 motifs in it. And these all do something. They're like the little hold tools. Those things consist of 4 to maybe 20 proteins at the most, usually less than 10 amino acids, I mean. And that is the part that you can't usually mess with without screwing up the protein. But you'll either screw it up or you'll change it into something else. Those are the most highly conserved parts of the genome, all the way back to bacteria, to prokaryotes. Okay, and there's a reason why they're highly conserved. The rest of the protein can change and function can change. And if you mutate a protein, there's absolutely no reason why it cannot become more efficient or less efficient. Okay.
Okay.
It depends on what, and that's just protein chemistry. I mean, you can read the chemistry. It has nothing to do with philosophy.
What you just said is completely bogus science, and no scientist in the world, no scientist in the world would repeat what you just said.
Because you found a quote, you cherry-picked a quote out of a paper where he's telling you, basically, if you read this paper, they will tell you how proteins evolve.
No, in their imagination, Mike. That's the difference. What you're talking about is what's in your imagination versus what's
your imagination that says every protein change is going to kill us.
Scientists do not publish in the science journals that proteins are tolerant of mutations, which is what you said. That is bogus, Mike. What you just said is not true. Protein codes are extremely intolerant of mutation.
No, they aren't.
Well,
what happened to you? Chance to read the paper. Did they
say the accepted paradigm that proteins can tolerate nearly any amino acid substitution has been replaced by the view that deleterious effects of mutations, and especially their tendency to undermine the thermodynamic and kinetic stability of a molecule, is a major constraint on protein evolvability. So, Mike, what you just said is not true. You're trying to tell people that protein codes are highly tolerant of mutation, and that is not true. Scientists don't publish that.
One paper
Show me one scientist, Mike, that says that proteins are highly tolerant of mutations. Show me one.
You want me to go and cherry pick?
I want one.
You want
Mike, let me tell you one. If it's not relating to what evolutionists believe happened in millions of years ago, but if it's talking about what's observed to happen to proteins in the now, okay? If you can provide me one statement, Mike, from any scientist who's published a paper in a major science journal who says protein codes are highly tolerant of mutations, I will package everything I own and send it to you by FedEx tomorrow.
What do you got? What do you got?
Well, I've got computer, I've got an automobile, I've got money in the bank, I've got furniture, I've got a huge compact disc collection. Send it all to you, Mike. By FedEx, free charge. Find me one statement by one microbiologist.
It says generally. It doesn't say.
It says that proteins are highly tolerant of mutation, and I'll send you everything I own. You can't find one.
Okay.
But that's what you're telling people, Mike. You're telling people lies now. I'm being nice.
False dichotomy. Okay. You said either it has to be every mutation has to be highly tolerated, or every mutation has to not be tolerated.
The language you used implied.
They said generally, Neff.
That's
generally,
right.
You know,
right, generally. That means the majority of the time. the majority of the
Most
time.
of the time, but not always.
That's correct. That's
Okay?
correct.
It's the not
of the time.
always that causes mutation.
Right, and the not always is really rare because it's a 1 in 20 shot. 1 in 20 is the minimum.
Find me a paper where it says that mutations always result.
I didn't say always. I didn't say.
Okay.
I even told you how it's not.
And
You
I
have a
didn't say
minimum
they're
of a
always
1 in 20
beneficial either.
chance.
They're
So,
beneficial
Mike,
to the
here's
time.
the thing. You misled people when you said you implied that proteins are highly tolerant to mutations.
They are
They
highly
say and they are not. That's not
They are.
scientifically correct.
They are.
Mike, I just gave you one statement in numerous papers published in science journals that disagree with you.
Wait a minute, numerous papers? You showed me one paper here.
Yes. How about McGraw-Hill's publications on mutation by base substitution? How about predicting the effects of amino acid substitution on protein function? How about the combined effects of amino acid substitution and indels on the evolutionary structure and proteins? How about
send me all those links. I'll take a look at them.
Yeah. So I mean,
it's getting late now.
The typical effect of a mutation on a protein code is a protein of lesser reduced efficiency or non-function. But you're telling people that proteins can tolerate all kinds of mutation. Mike, that is not.
They actually can.
They are highly intolerant.
And that's something I know because I know a bit about protein.
Okay, so I'm just going to put it like this to the audience. When you get through listening to this debate, go look up in your Google browser or your Chrome browser for Firefox. Search for proteins and mutation effects. Just look for that. Start reading, and what you're going to find is a wealth of information that tells everybody Mike is wrong.
I'm reading a book right
What
here.
you've said is pseudoscience, Mike. That's not science.
I'm reading a book right here about mutation.
I was hoping you'd come in here with absolute truth about science and tell us about why you believe things are true instead of contradicting what's published in the journals so thoroughly. I just can't believe this.
What am I contradicting? I said.
Well, your idea that proteins are highly tolerant to mutation.
They are.
They are not.
They're
highly intolerant.
They have to be. Okay, listen. How many people are in the world right now?
Oh, I don't know, 7 billion probably.
8, I think. Do you think all of them have exactly the same genetic structure of the gene that makes their hemoglobin or their insulin?
How does that not?
Is it exactly the same structure or not?
If it's not, it's because it's because an amino acid that's capable of producing the same function has been substituted.
The insulin and the hemoglobin still work,
and that's rare.
Around?
Mike, you got a 1 in 20 shot just to get one amino acid that substitutes for another and still produce the same function. Otherwise, the shape of the protein is going to be different, and that's the cause of disease.
Okay, glycine and alanine, what is the difference? What does that do to it?
I'm just telling you, Mike, that changing a single amino acid.
Will you listen?
Excuse me.
Do you want to hear the science?
Mike, I'm just telling you, the change of a single amino acid in a protein is enough to reduce its functionality or make it completely functionless.
If you replace glycine with alanine, it won't have any effect at all.
Right, and that's a 1 in 20 shot.
If you replace...
Now, if you want to think that evolution proceeds on the back of creating endless number of diseases,
redundancy in the code, so you could have all kinds of mutations that don't even change the amino acids.
Mike, do you realize that virtually every disease known to mankind is produced by a mutated protein? The vast majority of human diseases are caused by mutations to protein sequences, which modify them.
You are here today was caused by mutation.
Is that not true, Mike?
You would not be here today without mutation.
Is that not true? That the majority of times when a protein experiences a mutation, you're saying it doesn't reduce its fitness. The protein's fitness is not negatively impacted.
Neutral basically neutral substitution. It's a neutral
What
mutation.
what percentage of mutations to
Are
protein
neutral?
codes constitutes neutral ones?
Okay,
Yes.
if we're looking at the whole genome, I'd say 99% are neutral.
Wow, Mike,
99% do
that's
nothing.
bizarre, Mike, because there ain't a scientist in the world that would agree with you.
I believe there are.
No, Mike, you can't quote me one. When
Okay.
you do, I'm going to package everything I own and send it to you.
I just want the money. It's getting late. So you mentioned a whole bunch of books a little while ago. One of them was Mutations by Base Substitution or something like that.
Yeah.
Could you do me a favor? You listed like 6 things. Could you send me that list? Email.
I will. Yeah.
You promise?
Yeah, I'm emailing to
Okay,
you.
I think I got we got to go to questions if you have any. And
Yes, I want to read one thing for you first, though. This is from Predicting Amino Acid Changes by Protein Function. Single nucleotide polymorphisms are used as markers in lineage and associated studies to detect the regions in the human genome that may be involved in disease. Single SNPs encoding in regulatory regions may be implicate in disease themselves. Non-synonymous SNPs that lead to amino acid change in the protein product are of major interest because amino acid substitutions currently account for approximately half of the gene lesions responsible for human inherited disease. Half. Okay, so Mike, your statement that proteins are highly tolerant of mutation and the vast majority of them have no negative effect is refuted by just what I just read to you. They state, I'll quote them again.
Add that paper title because I can't.
An amino acid substitution will affect protein function and hence they state over half. So that's just that one paper.
Okay, what did they say again?
Okay, let me find it again. Okay.
Show me the paper.
Because amino acid substitutions currently account for approximately half of the gene lesions responsible for inherited disease. Half. Amino acid substitutions, half of them are the product of human disease. That's a far cry from the vast majority of amino acid substitutions having no effect, like you said. That's you're 50% wrong right there.
I have a raccoon fight going on in the backyard. Could you post that paper while I go out and look and see what's going on?
Sure.
Yeah, I have the questions too. I have 2 questions. If anyone wants to send in questions, just tag me.
Okay, sorry, I didn't. I had to make sure my cats weren't involved in the fight. So, okay, link that paper, please. Also, and either put it in. Did you put it in the chat or did you link it?
Yeah, I put it in the chat. It's titled SIFT: Predicting Amino Acid Changes That Affect Protein Function.
Okay, thank you.
Yeah.
So send me those other links, and we'll get the questions here.
Yeah.
And I'll take a look, but I will provide you with some information to back up what I said about proteins being extremely.
Okay, Mike, just get ready to receive everything I got. When you have a statement,
you can punch them in the head. They don't care. Okay, proteins are durable. That's how life happens. We'd all be dead.
They're highly intolerant of mutation. Amino acid substitutions are they are very intolerant of that.
I got the COVID. Let's move on.
All right, I got the question. So this first one is from Science is Observable. Question for Speed. Can you give one example of a beneficial mutation that is actually relevant to macroevolution? For your information, speciation is irrelevant to macroevolution. So that's from Science is Observable.
Okay. Could you please repeat that?
Sure. Can you give one example of a beneficial mutation that is actually relevant to macroevolution? FYI, speciation is irrelevant to macroevolution.
Okay, macroevolution is not going to involve one beneficial mutation, so I can't. I can give you an example of beneficial mutations that have caused a difference in phenotype, that sort of thing. But no, that's you're asking for a book length lecture on basically like how a tetrapod limb developed, and that would take. I did this last time too. It would take hours to explain this. I'm sorry, but macroevolution happens over periods of time that are maybe 100 years or greater, and in fact, you guys believe in macroevolution because you believe in the whole Noah's Ark split into many kinds of kitties or whatever thing. How that happened, the mutations that made that happen there were hundreds of them, hundreds, maybe thousands. Okay, and it's not possible to give you one example.
Thank you for your answer there. Nephilim, you can respond to that if you want.
Okay, I'm sorry. I was reading and researching something. I'm so sorry. Ask the question again. Ask the question again, please.
Sure. It's can you give one example of a beneficial mutation that is actually relevant to macroevolution?
Macroevolution.
Yeah.
No.
So that answers that. This question by Anthony. He's been really been ready for this question to be asked. So here it is.
Before you do that, I want to point out something. I want to share something with Mike real quick. Mike, I think we're talking apples and oranges here. I was talking about amino acid substitution. Remember, that's what I was saying. Okay.
Right.
I think what you're talking about is single base nucleotide changes to amino acid codes in the DNA that are part of the DNA. Though DNA is pretty tolerant of those, but DNA is not tolerant of amino acid substitutions. Highly intolerant of swapping out amino acids. It can accept mutations that change out a single base pair and still produce the same amino acid. See, but when you get a mutation that changes the amino acid, swaps out an amino acid for another substitutes, then you have problems. And
I will double down.
I
did mean amino acids, that the amino acids can change, and protein.
Okay, so then you're wrong. Okay, what's the next question?
Anthony's been itching for this question. So hey, okay, so let me look at this. Please ask SpeedOfSound about all the RNA world problems and how chemists must use purified reagents and manipulated controlled that do not resemble prebiotic conditions.
Okay, the reason that they use purified reagents when they're investigating abiogenesis is because they're trying to find one particular function. They're trying to find one piece of it. I mean, if they took a pile of mud and threw it into a flask, and then they discovered something happened, how would they know what the hell happened? I mean, it's got to be purified reagents. There are all sorts of the RNA world is something that I buy into, because RNA is remarkable in how it can fold. It has it's like its own little protein, basically. You fold into some pretty elaborate machines, and very small RNAs can have function. And I'm with RNA world. Now, the criticism is that we have to purify, and the other criticism is that scientists can't do it. You know why? Because intelligent design cannot design life. Life is not intelligently designed. We can design automobiles, we can design little experiments in a laboratory, but we cannot design life. We are not capable. We're just apes. Okay?
Thank you. And Nephilim, you can respond to that if you want.
Evolutionists don't say we're apes. Professional evolutionists don't say humans are apes. They say we're related to apes, but they don't say we are apes. Right. Well, you have that opinion. They have theirs. The evolutionist scientists don't say we're apes. They say we're related to them.
I'm not much on phylogeny. That would be Aaron Ross' thing, but I'm pretty sure he thinks we're apes. So I will ask. Ask Eric if we're apes. She knows.
Okay, this one's from Science is Observable. Again, question for Speed. Do you consider directed panspermia a possible explanation for organic evolution? And
No,
if so, then isn't that taking a leap from scientific method to science fiction?
no, I don't. Panspermia, probably bullshit. Unnecessary. I don't buy panspermia. They did find ribose on a meteorite, though.
Huh. Thank you. So this one's from Landon Freeman.
Oh, I like Landon.
What do you think of biochemists that are skeptical of an abiogenesis under a naturalistic scenario? Two examples are Michael Denton and Franklin Harold.
I don't like Landon anymore. Okay, biochemists now, it's really amazing, but molecular biologists are more prone to buy into evolution and abiogenesis than biochemists. And part of the reason for that, now here's my theory, and this is just a theory, is that biochemists draw these little diagrams. They draw lines between little functions, and they think it's a machine. It looks to them like a machine. They even draw them so they look like gears or like things walking. Well, that isn't chemistry. That isn't reality, okay? That is in their head. They're making it up, and they believe these things. So that's why biochemists have a hell of a time. The other problem is that in the laboratory, they have to go through a great deal to make something happen, okay? Life doesn't. Cells do that all the time. They make things happen. Chemists have a hell of a time because man is not all that smart.
Thank you. You can respond to that, Nephilim.
Well, I think that they're on to something. Modern science has refuted evolution theory. So we have a lot of scientists today who are in support of the idea that life was designed and that evolution is not true,
Not
that
that many.
special creation is true, because of the evidence from science.
So the last question is actually for me. So how could you say that information can be added to the genome when there is no law in nature that adds information? And that's for Speed of Sound.
Okay, there's a law that adds information. Information is basically any change moving from one part of space to another. Basically, you have stuff and you have stuff not. You have binary 1, binary 0. You have a chlorine atom next to a sodium atom. That is information. That happens all the time. The kind of information you're talking about is more complex, granted, but it happens all the time. Rivers flow by information. They follow their bed by information. I could get into the philosophy of information all day long because I think about it a lot.
Yeah.
Well, let's have a debate about that sometime. My response to that is the kind of information that exists in genomes is complex specified information. It's precise, it's prescriptive, it's functional. This is what's being published in the mainstream science journals today, that it's prescriptive information, that it's functional information. And what Speed might be talking about is Shannon information, but Shannon information doesn't actually technically qualify as information. It's just data about information. The information in a genome is complex, specified, prescriptive, and functional. And there's never been an example of whereby where mutation is able to generate, or any biological process able to generate new information in the genome of any living thing. Numerous scientists, even evolutionist ones, have acknowledged they don't know of any such thing. So mutations can't build information. Information is knowledge conveyed from a sender to a receiver using a language agreed upon by both parties. And since those are processes of intelligence, it's impossible for mutations to create information.
Evan, you and I are examples of that having happened.
Well, that's what your faith is. I understand your philosophy.
I understand that. What's wrong with faith? I mean, yeah, faith. What's wrong?
Well, my faith is not blind. I don't have to rely on what I don't know.
What do you mean by blind faith?
Well, I don't. The scriptures describe Christian faith And I apply it the same way in science. Faith is the substance of things hoped for, the evidence of things.
Well, mathematics and molecular biology describe my faith. It's not blind.
But that doesn't. Your faith that information is going to rise by mutation isn't supported by science.
Oh yeah, it is.
No, I disagree with that. We'll have a debate about it sometime.
Every paper that you linked is about evolution and how things evolved. And
well, sure. Evolution has infected science so heavily you can't hardly get a job in biology unless you believe it and then talk about it.
Right.
Okay. We know that, right?
You're hoodwinked.
We know that. Let me state this. Henry Quasitor, the famous information theorist, said, "The creation of information is habitually associated with conscious activity."
Yeah, and he's full of shit.
Well,
anyway, we got to go, guys. It's getting late.
Yeah, I think SFT said give him 1 minute because I think you wanted to finish it. If we can give him just 1 or 2 more minutes.
Yeah, no, I'm here. I'm here, Praise.
Oh no, you're gonna pick on this too.
Yeah, we're gonna have an hour debate now, Speed. I'm just kidding.
Are you gonna weigh in?
No. I'm just gonna close it off. I want to say that this was a really, really good discussion. Audience had fun. I had a blast listening to it. Lots of good topics discussed. So I want to thank again the debaters for doing this and giving us their time. So I do want to let the audience know, check in tomorrow, 9 EST. We'll have a discussion on epigenetics, beneficial mutations, and evolution between Raw, Matt, and Erica. So we're looking forward to that. Any last words from the debaters before we shut her down?
I want to talk about epigenetics with you someday. Evan, I hope that I got you excited and got you feeling good. So.
Oh, I enjoy that stuff. Always enjoy refuting evolution. Mike, you're a likable fella. I enjoy talking to you. I hope we can do this again.
Hope you're well.
Okay. Thank you. I hope you too. If you're sick, I hope you're getting over it quick.
Just got a little cough. It worries me, but I think I'm okay. We've been isolating, so I'm good.
Yeah. Okay. Well, how long you been sick with it? How long you had this cough?
I think it's cat hair. I don't know. We've isolated for 3 weeks, and I've had kind of an intermittent cough for 3 weeks.
I doubt it's a virus then, because it would have come to fruition long before now. Well, viruses don't wait, maybe 2-3 days before they hit you hard. You know what I mean?
I used to smoke 6.2 packs a day, so.
Oh wow! Okay,
that was 9 years ago. So I'm suffering from that. Okay, good enough. See you.
All right, guys, we're to shut it down. Thank everyone in the chat. I'll let you shut it down, SFT. Actually.
Hey, you too. Thank you, Praise and SFT.
Likewise,
take care,
man. It was a pleasure.
Okay, bye.
Later, guys.